This video is on a genetic disease known as adrenoleukodystrophy, or ALD. ALD is a genetic disorder that occurs primarily in males. It mainly affects the nervous system and the adrenal glands, which are small glands located on the top of each kidney. In this disorder, the fatty covering known as myelin that insulates nerves in the brain and spinal cord is prone to deterioration, which reduces the ability of the nerves to relay information to the brain. In addition, damages to the outer layer of the adrenal glands, known as adrenal cortex, causes a shortage of certain hormones. This adrenal cortical insufficiency can cause weakness, weight loss, skin changes, vomiting, and even coma. The prevalence of adrenal leukodystrophy is 1 in 20,000 to 50,000 individuals worldwide. It affects males more severely than female, and this is because it's an X-linked recessive disease. This is an MRI of individuals with ALD compared to individuals without ALD. The images on the right is the image of a normal brain, while the image on the left shows the brain of people with ALD. As you can see, there are a lot of white areas in the middle, which is a result of the degeneration of the white matter. There are 3 forms of ALD. The first one is child cerebral form, and it is a form that develops between the age of 4 and 10. Over time, children with this type of ALD have difficulty reading, writing, understanding speech, and comprehending written material. Additional signs and symptoms of this form includes aggressive behavior, vision problems, difficulty swallowing, poor coordination, and impaired adrenal gland function. The rate at which disorder progresses is variable, but it can be extremely rapid, often leading to total disability within a few years. The life expectancy of individuals with this type depends on the severity of the signs and symptoms and how quickly the disorder progresses. Individuals with cerebral form of ALD usually only survive a few years after symptoms begin, but they may survive longer with intensive medical care. The second type is adrenomyeloneuropathy, and it appears between early adulthood and middle age. Affected individuals develop progressive stiffness and weakness in their legs and experience urinary and genital tract disorder, and often show changes in behavior and thinking ability. Most people with this type also have adrenal cortical insufficiency. In some severely affected individuals, damages to the brain and nervous system can lead to early death. The third type is adrenoleukodystrophy, which is the mildest of the 3 types, and their only symptom is the adrenal cortical insufficiency. This form is also known as the Addison disease. In these individuals, adrenal cortical insufficiency can begin anytime between childhood and adulthood. However, most affected individuals develop the additional features of adrenomyeloneuropathy type by the time they reach middle age. The life expectancy of individuals with this form depends on the severity of signs and symptoms, but they tend to live longer. For reasons that are unclear, different forms of adrenal leukodystrophy can be seen in affected individuals within the same family. So, here's the cause of ALD. ALD is caused by mutations in the ABCD1 gene located on the X chromosome, which makes this an X-linked disease. The ABCD1 gene provides instructions for producing the adrenoleukodystrophy protein, or ALDP. The ALDP is located in the membranes of peroxisomes, which are small sacs within cells that process many types of molecules. It is responsible for bringing groups of fat molecules called very long-chain fatty acids, or VLCFAs, into peroxisome where they're broken down. The mutations in the ABCD1 gene results in a deficiency of ALDP. When this happens, the transport and subsequent breakdown of VLCFA is disrupted, causing abnormally high levels of these fats in the serum and tissues of the central nervous system. The accumulation of this fat can be toxic to the adrenal cortex and myelin. Research suggests that the accumulation of VLCFA triggers the inflammatory response in the brain, which could lead to the breakdown of myelin. The destruction of these tissue leads to the signs and symptoms of adrenoleukodystrophy. So this demonstrates how the LDP help transport the VLCFAs to the peroxisome for it to be broken down. With not enough, like in ALD, with not enough LDP, the VLCFA tend to build up and ultimately leading to a deterioration of myelin. So inheritance pattern. So like the way I said before, this is an X-linked recessive disease, meaning that only one mutated copy of ABCD1 gene is needed in male and two mutated copy is needed in female for this disease to show. However, sometimes female carriers may develop a less severe form of ALD. This is a typical pedigree of X-linked recessive disease, which is what ALD is. As you can see, in the first generation, the father is diseased with ALD, and he passed down the X chromosome to his daughter, making his daughter a carrier for the disease. As you can see, in the third generation, individual one has ALD, and it's because it received a X chromosome from the mother in the second generation that has a mutation of the ABCD1 gene. And since males only have one X chromosome, only one X chromosome with mutation on ABCD1 gene is needed for them to have the disease. Right now, adrenoleukodystrophy has no cure. However, stem cell transplantation may stop the progression of LD if done when the neurological symptoms first appear. The main goal of treatment at this point is to relieve the symptoms and slow the progression of the disease. Treatment options include stem cell transplant, adrenal insufficiency treatment, medications, and physical therapy. The stem cell transplant can help slow down the progression of LD in children if it's diagnosed and treated early. It may be taken from bone marrow to bone marrow transplant. Many people with ALD develop adrenal insufficiency and need to have regular adrenal gland testings. Adrenal insufficiency can be treated effectively with corticosteroid replacement therapy. Also, medications may be prescribed to help relieve symptoms like stiffness and seizures, and physical therapy may help relieve muscle spasms and reduce muscle rigidity Patients with ALD may even need wheelchairs and other mobility devices if needed. In a recent clinical trial, boys with early-stage cerebral ALD were treated with gene therapy as an alternative to stem cell transplantation. Early results from gene therapy are promising. The disease progression stabilized in 88% of the boys who participated in the trial, and additional research is necessary to assess the long-term results and safety of gene therapy for cerebral ALD. So, meiosis is the formation of gametes or sex cells. During meiosis, gametes are formed and each containing half the genetic information from its parents. In meiosis 1, the pairs of homologous chromosomes are separated from each other, and a process called crossing over takes place during prophase 1, in which homologous chromosomes overlap each other and exchange DNA in their temporary tetrad structure. This creates new combination of genes in the gametes that are not found in either parent, contributing to genetic diversity. In meiosis 2, the sister chromatids are separated and the four gametes are formed, each with half of the genetic material from its parent cells and genetically unique from the other gametes. These gametes will go on to fuse with another gamete, sperm fuses with egg, to form a zygote through the process of fertilization. And this is how life is formed and diseases are passed down. The daughter cells or like gametes from meiosis receive the chromosomes from their parent, which are almost identical if no crossing over happens, and if the parents have the mutation on their X chromosomes, it will be passed down to their daughter gametes, which will show up in their future generation. If two of the X chromosomes are affected in female, then it will have ALD, and if one of them have the mutation on the X chromosome for males, then they will have ALD too. And this concludes the video on adrenal leukodystrophy.